All right, so this is a goodness of fit test. I hope you realize that, because there is a row of data. It's not a table, it's a row, so it's goodness of fit. And because they didn't give me any weights, so I know that there's going to be an even distribution or a uniform distribution. And the deal is there are 7 days in the week, so it should be 1/7. So if you add these all up, I get 140, right? 140. So 140 divided by 7 is 20. So my expected value is 20. All right, and so I wrote down the expected values, and then my HA is that the distribution of births is even across the days of the weeks. All right, and let me just go write my HA and write it in a different color. And that is going to be the distribution of births is not even. I don't know if I'm going to be able to write the distribution of births is not even across the days of the week. I am so sorry that I had to do that. Okay, so let's go do the math for chi-squared. So you need to say chi-squared is equal to, now it's going to be the observed minus the expected over the expected, and I'm going to square that. I have to show the first two to show a pattern. Then I'm going to do dot, dot, dot. And then the last one, so I know where to stop. You can't stop in the middle. And don't forget to tell me what is equal to. All right, so I get equal, that is 7.6. And so the probability that chi-squared is greater than 7.6 is equal to 0.3692. 0.3692. And the degrees of freedom here are categories minus 1, which is 6. So with a 3.69, we will fail to reject my HO, since my p-value of 0.3692. Now, do I say is big or do I say is greater than? I gotta see, what do I have in alpha? Is greater than alpha, which is 0.05. And we're going to keep the HO, so there is evidence to suggest that the births have an even distribution across the days of the week. Okay.